Hey, advanced geometry students, it's Mr. Donaldson, and I'm here today with you to talk about section 9.1. We're going to begin chapter 9, which is the Pythagorean theorem. But one thing we need to do prior to learning about the Pythagorean theorem is just do a little algebra review. We're going to do that right now. We're going to review simplifying radical expressions and then multiplying them as well. Right? A radical expression is any expression that contains a radical symbol. So this one got a little cut off, but you'll notice radical symbol would look something like that. So that example there is 3 root 2. In that case, that's square root 2. You could also have cube roots and fourth roots, but because we're dealing with the Pythagorean theorem, we're just going to deal with square roots. And you'll see why when we do that. When you're multiplying radical expressions, you just simply need to multiply the coefficients. Think about those like the outside numbers. So in this case, 3 would be the coefficient. And then also you multiply the radicands. Those radicands are the inside numbers. So in this case, that 2 would be your radicand. So just some quick examples of this process. All right, if we look at this first example, example 1. When I want to multiply 2 root 5 times 3 root 7, I'll multiply first my coefficients. 2 times 3 gives me 6. And then I will multiply together the radicands. I'll leave them in the radical symbol, and I'll get root 35. So the product of 2 root 5 and 3 root 7, 6 root 35. In this next example, it looks a little bit different because this first factor doesn't have a radical symbol. But you could rewrite it with 1 if you want, because square root of 1 is just 1, and 5 times 1 is 5. It's unnecessary, of course, but just showing you how this works. Excuse me. When I'm multiplying the coefficients together, I get 5 times 3, which is 15. And then when I multiply my radicands together, the 1 times the 3 gives me root 3. So without having to actually rewrite it like I did in this case, you could have just done 5 times 3 is 15 and left the root 3 there as well. In this next example, kind of a similar idea. We're missing the coefficient, but as we know, there's always a coefficient of 1. So in this case, if I multiply my coefficients together, 3 times 1 is 3, and root 2 times root 2 is root 4. However, we want to make sure our answers are in simplest form, and we all know that the square root of 4 is the same thing as 2. So instead of 3 times the square root of 4, that's just 3 times 2, and of course, that is 6. Perfect. So next we'll talk about simplifying radicals. When we're simplifying radical expressions, there are 3 rules to follow. And the first rule is that we are to have no perfect square factors other than 1 in the radicand or under the radical sign. All right, in order to be good at this, it's really important that you quickly know your perfect squares. So I made a list of perfect squares here for you. This would be something that you would want to study. All right? If you know these really quickly, it makes simplifying radicals easier. So for instance, when I look at number 1, I got the square root of 12. This is not in its simplest form because it's violating this first rule. 12 has a perfect square factor, the factor of 4. So I can rewrite this as the square root of 4 times 3. And then, just like we did when we multiplied radicals together a second ago, this can be rewritten as the square root of 4 times the square root of 3. And then, of course, we know the square root of 4 is 2, and then we still have our root 3 there. So 2 root 3 is the same exact value as root 12. This is written in simplest form. For example 2 here, the square root of 80. So there's 2 ways to approach this, I would think. If you really know your factors well, you would approach this in a faster way. But let's pretend you don't. Let's say you're like, hey, 80, that's 20 times 4. So let's say you said that this is 4 times 20. All right, so then you break this down and you say, okay, well, that's the square root of 4 times the square root of 20. But then hopefully you recognize that square root of 20 still also has a perfect square factor. It's also 4 times 5. So now we get the square root of 4 times the square root of 4 times the square root of 5. Because again, root 20 is root 4 times root 5. Now, square root of 4 is 2 times, square root of 4 is 2 times square root of 5 is just square root of 5. And then I can multiply my 2 by 2 together to get 4 root 5. Now, if you had better number sense with your perfect square factors, you would notice that the square root of 80 is just 16 times 5. And the square root of 16 is 4. And that leaves the 5 inside. So knowing those perfect square factors really well does make it easier because you can identify the larger ones and simplify in one step. Rule number 2, there can be no radicals in the denominator of a fraction. So we want to get rid of any radicals that are in the denominator. And to do this, we need to rationalize the denominator. And so what we're looking to do is we are looking to make the denominator a perfect square. Because the way we use a radical symbol, for instance, the square root of 9, well, look, that just becomes 3. The radical symbol disappears. That's because we could use it. We could actually take the square root of that number. All right? So that is our objective, and we're going to decide what number I can multiply that denominator by to make it a perfect square. But whatever I multiply by the bottom, I also need to multiply by the top. So in this first example, I need to make this 2 a perfect square, and the easiest perfect square I can make that will be the square root of 4. So I'm going to multiply both the top and the bottom by the square root of 2. When I do that, up top, I get 6 square root of 2, and on bottom, I get the square root of 4. Of course, the whole point was for me to be able to use that radical sign, and now I can, because then I get 6 root 2 over the square root of 4 is simply 2. The last thing to do in this process is just do any simplification. We know, of course, that 6 divided by 2 is 3, so we get 3 root 2. So 3 root 2 would be the equivalent form, or the simplified form, of the original radical expression 6 over the square root of 2. All right, for example 4, I want to make 8 a perfect square. All right, oftentimes students will make that a 64, but when you do that, you're just going to have bigger numbers that need more simplification. You want to make it the smallest perfect square possible. And I know that I can make 8 the square root of 16 super easy if I multiply by the square root of 2. So I'm going to do that on both the top and the bottom. So on top, I get 4 root 2, and on bottom, I have the square root of 16. Of course, the point is to actually use the radical on bottom, and I can. So on top, I get 4 root 2, and on bottom, the square root of 16 is just 4. And same thing, we want to simplify when possible, and that 4 over 4 divides to give me 1. So I get 1 root 2, or just simply the square root of 2. The final rule with simplifying radicals is that we do not want to have any fractions underneath the radical sign. So in this case, I've got a radical of this quotient 4 over 25. So rather than do that, what I'm going to do is I'm going to just separate this into the square root of 4 over the square root of 25. And now I can simply do the square root of each, and that gives me 2/5. That one was pretty easy because both the numerator and denominator were perfect squares. But of course, that won't always be the case. So now if we look at number 6, same thing. First thing I'll do is instead of having a radical of a fraction, I'll do a fraction of a radical expression. And now I'll have the square root of 9, of course, which is 3 over root 5. Let's come down here and we'll finish the simplification. So 3 over root 5. So I have satisfied and fixed rule number 3. There's no longer a fraction under my radical sign. But the problem is now I'm in violation of rule 2. I cannot have a radical in the denominator, so therefore I will rationalize. And to do that, I'm going to multiply both the top and the bottom, in this case, by the square root of 5. On top, I get 3 square root 5. On bottom, I get the square root of 25. Of course, we know the square root of 25 is 5. So that gives me 3 root 5 over 5. And that's it. I cannot simplify 3/5, so we are done. So that is simplifying radicals in a nutshell. So make sure when you're doing your assignment, you have these notes out and you're following all 3 of those rules. All right, the Pythagorean theorem video will be in a separate video, so just go find that in Schoology.